Hello everyone, welcome to Organolithium. So welcome to another video of the name reaction series. Now in this video we are going to discuss the Kumada cross-coupling reaction. So it is another kind of cross-coupling reaction. We have already discussed almost all these cross-coupling based reactions. So this is also a kind of carbon-carbon bond formations reactions by using a metal catalyzed reactions also. So first of all, to do this Kumada cross-coupling, we have an alkyl or aryl halides, and along with this Grignard reagent or this lithium based reagent, and to catalyze this reaction by using this nickel catalyst, or you can use the palladium catalyst along with the solvent and ligand, and then finally we can get this kind of coupled product. So this is your coupled product from this reaction. So in the year of 1972 the first discovered the two scientists, that is Kumada and Koryu, they first independently discovered this cross-coupling reactions. So this is quite similar to other reactions, but the reagents are kind of different. That is, we are using Kumada coupling, they are using the organo magnesium or the organolithium based compounds, right? So the first thing, that is the R1 and R2 groups are, it can be your hydrogen alkyl or aryl kind of thing. So these R groups can be alkyl, alkenyl or aryl kinds of moiety, and the X is your any kind of living group, so which is basically your halides like F and Cl and Br. So these kinds of organohalides can be used, and R4 are similar also like alkyl, aryl or alkenyl. And the ligand which is used over here, we know that PPAC is quite good a ligand which is used for the all types of cross-coupling reactions. So similarly we can use this PPH3 or DPPE, this kind of ligands, and along with this we have to use a solvent, and finally we can get this coupled product of these reactions, right? So see first the mechanism. The mechanism is quite similar to others mechanism, but we can use two different kinds of approach. First, if we use the nickel, there is another kinds of mechanism over here, and if we use palladium, there is another kinds of mechanism is followed over here, but the steps are quite similar in both the cases. So first we are starting with the nickel catalyzed process. So we are starting with the nickel catalyzed process. So this is your nickel catalyzed process. So we know we are starting with this nickel, which is in oxidation state of 2, and along with this 2 ligand, and its X2X can be your Cl or Br, all like these things, right? So we are starting with this, and we have to use this R4, actually this R4 MgX, that is kind of a Grignard reagent. So we can use this Grignard reagent over here. We have to use 2 equivalent of this Grignard reagent, and finally we can get this X, and this Mg can leave from the system in the form of MgX2. So we are getting this MgX2 from here. So this step is basically the transmetallation. So we know what is transmetallation. So this is your transmetallation step. Now the first step is basically this one. So we are using this Ln and this nickel over here, and along with this 2 R group is attached with this nickel. So we are getting this one, right? So after that, this R2 can leave from the system in the form of reductive elimination after using this one, that is your R1X, which are going to use over here. So R1 is basically, this step is your oxidative addition. So this is your oxidative addition step, and the remove after the reductive elimination of this R2 group, so that there is this type of group can leave from the system in this way. So this is your reductive elimination, right? So this is your reductive elimination, and finally the product that we get from here is this one, that is your R1, and along with this X. So this is your oxidative addition product. Now after that, now the catalytic process is start over here. Now we are using this RMgX, right? So we are using RMgX to remove this X from here. So the removal of this MgX2 from here, so this is your transmetallation step, and after that this R group is now attached with this nickel. So this R1 and along with this R group is now attached with this one. So we have the ligand 2 and this is in oxidation state of 2. Now the next step is from this reaction is the coordinations, right? So if we use this R1X from here, so we are using this R1X. So this is your coordination step. Now how this coordination will be takes place from here? So this is not too much difficult like this. So this is nickel 2. So it is now attached with this R1X bond and along with this R1, here is X and this ligand, and finally we can get to conclude this catalytic cycle. So finally we are going to get this R1 and R product from here. So sorry, this is not X, this is R. So after this reductive elimination we can get this R prime and R from here. So this step we know that is the reductive elimination step, and we can get this final coupled product, right? So this is all about the nickel catalyzed process, but the another method is quite similar to the other Higg coupling reaction. So similarly this kind of catalytic process also over here. So if we use the palladium catalyst, then what will be the process? Now we are starting with this palladium 0 or the palladium 2 complex, that is the pre-catalyst. So we can get this palladium 0 from here. So here we are starting with this palladium 0. Now after that we know what will be the next step, that this R1X group will insert over here. So this is your oxidative addition. So this is your oxidative addition step. So after the oxidative addition, palladium 0 is now is converted to palladium 2, and this is R1 and here is your X. Now after that you have to use this organolithium kinds of complex. So if we are using organolithium to transmetallate this palladium complex, so if we are using RLi, then we are going to get over here this LIX, right? And this R group is now attached with this palladium. So finally that we get over here this R1 and R along with this Ln, and here is the oxidation state of 2. And finally, to complete the catalytic cycle, these two groups can leave from the system in the form of reductive elimination. So this is your transmetallation. So this is your transmetallation step, and the next step is the reductive elimination. Right? So this is a reductive elimination, and this R1 and R2 are seen to each other. So we know that reductive elimination always takes place in the cis fashion. So this is your coupled product after this reductive elimination, and finally we can get this palladium 0 catalyst from this catalytic cycle. So this is all about the mechanism from this Kumada cross-coupling, which is quite similar and quite known to us because we already know that what is the mechanism of the Higg coupling, Sonogashira, Suzuki, Negishi, right? So this is also similar like that. Now let's see some examples that I think that will be very much helpful for you. So we know this is a carbon-carbon bond formation reaction, and along with that we have to use this alkyl halide, and along with this Grignard reagent or organolithium based reagents. So we know that carbon-carbon bond formation between these two compounds will be takes place. So we have this organohalide over here, so this bond, and we have this Grignard reagent type of thing, so along with this bond. So we know these two marked bond will couple to each other, and finally we'll get back to this major product. So what will be the major product? I'm not going to discuss the overall mechanism because as I already discussed that. So this bond is now attached with this one. So finally from this reaction we can get this one, right? So this is about the mechanism of this reaction. So we are using this palladium 0 catalyst, right? So now the next reaction is that if you have this type of compound, there is a two naphthalene kinds of system is given to you, and along with this nickel and along with this ligand is given. So it is all about the nickel catalyzed process. So we know we have the organohalide and we have the Grignard reagents. So this bond and this bond are coupled to each other. So finally the product that we get from this reaction is this one, because we have this methyl group over here. So we have this methyl group over here, and these bond and these bonds are connected to each other, so we can write this way. So these two bonds are connected like this, and here you have the methyl group over here. So here is the methyl, and along with this phenyl group is like this. So this is the major product from this reaction. So this is how we can easily functionalize the two different types of rings. This is a kind of heterocyclic ring, and this is a kind of naphthalene system. We can easily couple each other. Next thing is that the questions comes out the regioselectivity of this reaction. So we know that what kind of regioselectivity is being takes place in all the cross-coupling reaction, because this you have two bromine Br group over here, but this bromine is attached to this nitrogen, adjacent to this nitrogen, so that is why it is quite reactive. So this bonds is now attached with this indole carbon. So finally the product that we get from this reaction is this one, right? So this is Br, and we have this group that is methyl, and the finally that we get over here, right? So this is the how you can get the product. So this is also the palladium catalyzed based reactions. Next thing is that if we have this kind of substrate, so you can see over here this is a E isomer which is given to you, and from here we are using this CH2 double bond CH and MgBr. So this is a kind of Grignard reagents over here, and we are using this palladium catalyst and benzene and heat. So what we know, what will be the product, that is organohalides. Now this position and this position will take form of bond. So finally the product that we get, so here is your methyl group, and you have this methyl group over here, and this bond is now connected with that one. So this is how we can get this product from this reaction. So this is all about the Kumada cross-coupling, along with these examples and the mechanism of two different kinds of catalysts. This one is the nickel and another is palladium. So I hope this video is very much helpful for you, and if you have any doubt, let me know in the comment section. I will definitely try to answer all those questions. And if you are new to our channel, please press the subscribe button and press the bell icon to get the earlier notification, right? So that's it for this video. Thank you so much for watching.